Hi everyone, in this lecture I'm going to continue discussing the type of external and internal mechanical contact force that we will encounter in this lecture. And let's get started with the external mechanical contact force that is usually we call it as a support reaction. So no matter which textbook that you use, usually it will provide a nice table that try to summarize the type of reaction forces or reaction support that typically encounter in static course. Okay, and in here I'm used the textbook from Hibbeler, the 2016 edition, and the first support is the smooth contact surface. Okay, so let's say that we have a surface in here, okay, and then we have a member, right, lying on the top of that smooth surface. Then the reaction forces is going to go upward if this member is transferring the force that is going downward. Okay. However, I have to make a note in here. If we have another case where this member, instead of transferring of downward force, is transferring an upward force, okay, I have to make a note that there is no reaction forces in here, because let's see that this is the surface, right, and this is the member. When I try to push this member downward, right, you can see that the surface is trying to prevent this member to move downward, right, such that there's a reaction forces that is going upward. However, when I try to pull this member upward, there's nothing on the surface that try to hold this member, right, such that there is no reaction forces at the bottom right here. Okay, and that's the reasons when we have a force going upward, there's no reaction forces, okay, for smooth contact surface. And of course there's no friction force in here because we are talking about a smooth surface, right? The second type of support is what we call as a roller and rocker, and there are many variations of this type of supports. So in the textbook we can call it roller, we can call it a roller or pin in confined smooth slot, we can call it member pin connected to collar on a smooth rod, and we can call it rocker. Okay, so in problems usually I will use triangles with 3 circles at the bottom of the triangle, or just as one circle to represent this type of support. Okay, and for this type of supports the reaction forces is only one. So let's say that we have a roller support in here, right, and this is the member. When the member transfer a downward force, then the reaction forces is going upward. Okay, and then so right now when the member is transferring an upward force, then the reaction forces is going downward. Okay, so in contrary with the smooth contact surface, right now there's a reaction forces when the member is transferring upward forces. Okay, so what does it mean? Right now we have this roller support, okay, that is trying to prevent all of the motion of this member in the vertical directions. So when I push, it restrains the motion, and then when I pull, it's also restrain the motion, such that so that there will be a reaction forces in these vertical directions. Okay, whether it's going upward or going downward. All right, and the reaction forces for smooth contact surface and roller is always perpendicular to the surface. Okay, so in here it's always perpendicular to the surface. Okay, so if I have an inclined surface, then it will be perpendicular to that inclined surface. Okay, as shown in here. All right, Some of you may ask, how come there is no horizontal force in here then, right? How come there's no horizontal force in here? So it's a very good questions, and one thing that I have to make a note in here is that reaction forces only exist in the directions where the motion is restricted. Okay, so I repeat again, reaction forces only exist in the direction where the motion is restricted. So for this roller, the motion is restricted in the vertical directions. Okay, whether it's going downward or going upward is being restricted. However, this roller cannot restrict the motions of the structure in the horizontal directions. So the structure is going to be able to free to move horizontally. So this is the roller, this is the member, so it's going to free to move right here. Since it's able to move in the horizontal directions, there is no reaction forces in the horizontal direction. Okay. One motion that is not being restricted by roller is what we call as rotation. So if, for example, if this is my roller, right, it also cannot resist these rotations of this member. Okay, so you can see that the member is freely rotate. Okay, and let's continue with the next support reactions, which is external pin or hinge. Okay, so in here we are talking about external pin or hinge, and typically we use a symbol of triangle to represent this type of support, okay, when we're discussing the problems. Okay, for pin, there will be reaction forces in the vertical and horizontal direction. Okay, so for example, this is my hand is acting as a pin support at the bottom right here, and this is the member. Okay, we can see that the member is restricted from moving in the vertical direction, right? It's also restricted in translating left and right in here. Okay, so that we have a reaction forces in the vertical and horizontal direction. Okay, however, in here we see that the member is still free to rotate. Okay, so that pin, in the pin connections, there is no moment reaction. Okay, there's no reaction moment. Okay, so remember that in pin, only vertical and only horizontal and vertical motion because pin restrict the motion of the structure in the vertical and horizontal direction. Okay, and of course, once you already obtain the reaction forces in the horizontal and vertical directions, you can find its resultant. Okay, so using the method that we have discussed in previous modules. Okay, all right. The next type of support in here is what we call as a sliding support. Okay, and usually I use this symbol to indicate sliding support. Okay, so what is this sliding support looks like? Okay, so if this is the sliding support, okay, in here, this sliding support is able to move in the horizontal direction. Okay, it's able to move in the horizontal direction. It restricts the motion in the vertical direction, right? It also restricts the rotation of the member. So right now, the members cannot rotate anymore. Okay, so the only allowed motions is in horizontal directions. Okay, such that you can expect that if I have a member, right, supported with a sliding support, the reaction forces is only vertical reaction force, right? It can be going up or it can be going down, and also reaction moment, because it prevent the rotations of this member at this point, right? Okay, so there will be F and M, okay, and this F is usually perpendicular to the surface, okay. And the next type of support is what we call as a fixed support, okay, and this fixed support is able to restrict the motions in the vertical, horizontal, and rotational, such that in here, if this is the fixed support, right, sometimes I will use this thing to indicate the fixed support. The reaction forces will be Fx, Fy, which is the reaction forces in the horizontal and vertical direction, and also a reactional moment, okay, right? And the next type of support, I think most of you are familiar with this one, is what we call spring, okay, and the spring is a translational spring, okay. For a translational spring, the reaction forces is only one in the directions parallel to the directions of the spring, okay. So if the spring is directed in this direction, then the reaction forces is also directed in the same direction, okay. And it can be going up or it can be going down, depends on whether the spring is being compressed or being stretched out, okay. The next type of support is what we call as a partial fixity, okay, and this partial fixity is a combination of a pin support, right, and rotational spring. So since it's combination of a pin and rotational spring, it will have a support reaction of Fy and Fx in the vertical and horizontal directions due to the pin, right? And it also will have a capability to restrict rotational motion due to this rotational spring, okay? In here, there's a relations between the moment and the rotational angle theta in here, okay, and the moment and the rotational angle is related by Kr, where Kr is the rotational stiffness of the spring, okay. So that's it for all the types of external support reactions that we will encounter in this course, and I would like to move forward to the next topics related to internal connection forces, okay, and please differentiate it with internal forces, okay. So this is internal connection forces, and the first one that I would like to introduce in here for internal connection forces is what we call as a direct contact. So for example, I have body A, right, is a cylinder, and body B, another cylinder, right here, okay. And then when I try to draw the free body diagrams in here, I'm just concentrate on the internal connection forces, okay. Then there will be a force, which is the contact force between these two particles A and B right there, okay. And of course, if there's a weight that you need to encounter and there's a surface below this, you need to include those kind of a contact force and the weight force as well in your free body diagram, okay. The next type of internal connections, and this is more like a mechanical connections, is what we call as a moment release or pin, and in here I put a note that that pin is internal, so differentiate it with the one that we discussed in here, where this is used as a support. Okay. For moment release, usually the symbol that I'm using is just a circle. Okay. So for example, if I have a structure, let's label it A, B, and C. Okay. This member AB, this member AC is pin supported at A. Okay. And then this member BC is pin supported at B, right? And at C, there's an internal pin that try to connect these two member AC and member BC together. Okay, and when I draw the free body diagram of these two members, right, I will make a cut right at C over there. Okay, then I draw the reaction forces AY, AX, and then BY, BX. Okay, then in here I will see internal connection force in the vertical and horizontal direction, right? So we will have VC, VC, and NC, and C. Okay, so the reasons why we only have two internal forces, VC and NC, in here, because this internal pin can resist, can transfer the shear and axial force between these two members that connecting together. Okay, however, it's not able to transfer moment. Okay, so for example, this is one of the member, right, and this is the other member, and this pin connected at the top right here. You can see that this two member is free to rotate. Okay, since it is free to rotate, it cannot transfer the moment. Thus we can say the moment at C in here is 0. All right, since it cannot transfer moment, you can see that we can say that the moment there is 0. However, you can see that these pin connections can transfer the horizontal force, right? It also can transfer vertical force, right? So those two are the most common internal connection forces that we will encounter in this course. Okay, so if you listen to this term moment release, then you might expect that is there a shear release or is there an axial release as well? And the answer is yes. And I would like you to read the lecture notes that I have distributed, and in this lecture I will just discuss with the direct contact and moment release, because those two are the ones that are most commonly discussed in the problems in this course. Okay, and I think that's it for this lecture. And if you have any questions, please don't hesitate to let me know. Okay, and thank you for listening.